Hello to everyone. This one we are going to see how to do a Arduino programming because mobile robots most of the fundamental one is Arduino one. Now we have a latest one with ESP, or STEM, and even we can go with the Raspberry Pi 5 also. Okay, so being this is the fundamental one, the Arduino programming. So in the Arduino programming, the content which we are going to see it is a full one Arduino Uno configuration, how to do a structure and variable, data types, arithmetic, constant, and flow control, how that flow is go on, and digital input and output, analog input and output, time, math, and random and serial one. So this we'll see it now. So if you look at here, this is the reset button. If you want to reset your program, so you can press this button and it will done. Then you can connect with a USB connector where it can be connected with the ESP so that the program which you are doing with the computer, laptop or a computer, it can be transferred through a USB connector. And this is the USB interface. So this is the connected with the USB interface and the crystal oscillator to count the counting time and other things, and the voltage regulator and the power port. So you got to give the power port to the Arduino one. So power port, then microcontroller where all the program is carried out, and LED light. So the board is having a default LED light. For fundamental one, you can have with this LED light, and you are having a digital pin. So this is the digital pin and analog pin. Okay, here you have a analog pins, and here we have a 3 volt, 3.3 volt and 5 volt and ground. So whatever the pin you are is needed, you have to do the accordingly. So now if you look at the structure, general structure, while see this Arduino Uno, you have to download the software Arduino IDLE, where you have to type the program. So this void structure, so you have to give the statements, the statement you got to give, the loop, what performance you got to do a loop, that has to be given as here. So the example, if you are look at the setup one, so we are setting out the pin mode. The pin mode is nothing but where the input pin is set. So because if you look at the pin, you have several pins are there. Which pin you are giving as a input, that we have to give in it. Similarly, which we have to give the which pin is given as a output also. Here it is given as a pin as a output parameter. So digital write. So we are giving a pin input parameter turns into the very high, and delay 1000 means milliseconds. Okay, and the digital write, so after writing one it has to be turned off. So this is the one delay 1000. So this is the simple program for LED on or off, where the LED has to be on for 1 second. So 1000 means 1 second it has to on, then it has to off. So this is the fundamental how that Arduino programming is working. Now if you look at the function name, so you can go with your function name, your default one also you can go with it. So if you look at here, delay variable, so this is a delay variable, so we are defined with a variable v, and analog read. So analog read, potentiometer, where it is reading, it is giving a signal of analog, not digital. So it will have analog read. Then if you are dividing by 4, okay, what are the signal divided by 4, and return B. So this value is written in the digital one. So the function also you can write your own function. So the purpose of the function, like any other language, if you are using for a multiple purpose, this can be used. Okay, same function name can be used. So if you look at the block command, so if you want to put the command, so you see, you may know that how to write the program, what is the logic you have put after, say, after 6 months, after 4 months, if you want to recollect the program, you will be forgetting it, what say, syntax or what logic you have written. At that time, if you are giving a command, just like a commands, so that will help us to recollect your program, or another person to read what you have wrote. Because if it is a very simple program, everyone knows it. If it is a very lengthy program, it is difficult to understand. Okay, so here the line, if you want to after writing the one, this is the terminator command, semicolon, then double slash also you can give us a one as a command. If you want to give us a paragraph, this is the option. So two types are there. One is this is a single line command, and this is for the paragraph. Okay, so both types are allowed here. and input variable. So how to define the variables? Okay, it's a case sensitive. This one input variable 0, and whatever the variable you are saying analog read, you are reading it out. Okay, integer initially we are it's empty the space, then we are reading with analog read, so read, and whatever the value example is input read. Suppose the whatever the read you are giving with an input variable, if it is less than 100, then input variable is equal to 100. So this loop will be executed and delay the input. So 100 milliseconds it will be delayed. Okay. So this is the one. And the integer value, suppose variable scope. So integer value is a function to any function. So if you are putting in the loop you are putting a value with the command I to I equal to 0 to initialization. Okay, for loop you are having initialization of I equal to 0, then I is less than 20. So it will be having an increment of I plus plus means I plus plus, I equal to I plus 1, then float f. So this will be written back. Okay. So this is the only how to write the loop, like any other languages. This is also having it. And variable. So it is having a 4 different type of variable. One it is called byte. Byte is a nothing but a smaller command, is 8-bit character, and integer, where it is you can define the variable as an integer, or you can define the variable as a long type. Okay, long type means when you will be using an integer, and long is when the variables having a say memory size is less, computation time is less, then we'll go with the integer. When you are going for a long, the memory required to store that one, it will be higher. So when it is required only, you have to use it. So the float will have a decimal value. Okay, decimal point, float point 3.14. Decimal point, when you are using it, we have to use the float variable. And array, so if you look at the array, integer my array, so the values are arrays you can store the values, my arrays, value 1, value 2, value 3, like that also you can store it. Or integer my array is having a 5 unit, you can declare the rows 5 arrays. And if you want to extract the third point, okay, only a third value only I want to assign it, that also is possible. So both things are possible. And if you my array third means it's equivalent to 10. So now we are arraying with the 10, we are storing it. So X will be stored as a 10. Okay. Now array program, a simple array program, we'll see it. LED pin 10. So we are giving an integer LED pin 10. So LED is connected to the pin number 10, digital pin, and byte flicker. So we are creating one array name called flicker. So the flicker is stores 180, 30, 255, 200. So these values are stored in the flicker, and the pin mode LED output is LED pin. So LED pin, the 10th pin is given as an output. Okay. Then the loop. So if we are giving a loop integer I equal to 0, we are going to run with the I equal to 7. The terminator is 7. So I equal to I plus 1. Each time when it is running it, one increment will be there. So analog write LED pin flicker I. So this program is nothing but when I equal to 0, it will take 180. So 180 times it will delay. Okay, 180 times it will analog write. And the next time I equal to 1, it will go with a 30. And I equal to 2, it will display the 255 and goes on. Okay. So similarly, you can use the array as a flicker. You can again when you one, and you can use that one. Uh, So arithmetic, like any other language, we can do any type of arithmetic operation. Y equal to y plus 3, x equal to x minus 7, I equal to, so multiplication and division, addition, subtraction, multiplication, division. Everything is available in the Arduino programming. And here the compound assignment. Okay, if it is x plus plus means x equal to x plus 1, increment by 1. X minus minus means x minus 1, and x plus equal to y means y equal to x equal to x plus y. X equal to x minus y equal to x equal to x minus y. X into y means x into y, and x slash is equal to means it is x divided by y. So you can use the compound statement also for writing the program. And you can have the comparison statement. Here we have a comparison statement x equal to. So this is still be using for the loop and other things, and x is not equal to y, and x is less than the y, x is greater than y, x is less than or equal to y, x is greater than or equal to y. So we must remember how the programming syntaxes are given. The similar way we have to use it for comparison operator. Okay, any loop you will be using the comparison operator. And if you look at the logical operator if statement, if some variable, then we have to provide here the comparison operator, then another variable, and we will ask to do something. So here the example, if and then example, if LED input pin high, then do the things. So okay, you got to do some activity, else do the things B activity. Okay, and if you look at the else if statement, okay, do the thing, if the condition is valid, do the thing, or else if check another condition. This is first you check the 500 less than 500 or not. If it is not less than 500, if it is greater than 500, and check it is less than 1000 or not, do the things. Otherwise, if it is greater than 1000, do the third thing. So like that you can have with else, else if, or else. So this is the statement else if, else if, else. So like that also you have a statement, and you can have with a logical operator and operator also. And operator, so x is greater than or equal to and. This is the and operator. True only both conditions are valid. Okay, so here only one condition. If you want to put the both conditions are valid, this is the and operator. This is the logical or operator. This is the logical not operator. So this is also allowed here in the if and then statement. And true or false. So you can have a true or false also same thing, but it should not be a small letter. It should be case sensitive. Already I mentioned. So true case sensitive which has to given, and if it is equal to true, it will perform the one. And high or low. So digital write. So digital write, digital pin 13th pin you can have with a high. Okay, digital write high means it will have the highest value. Especially if it is the LED on, it will power will be on 13th pin. And similarly you can have with a digital write 13th low also, or 15 low also is permitted. And input and output mode, pin mode. See, you can note it down, the P should be a small one and M should be a caps one. This is a case sensitive. You should not change in a smaller case. It should be a pin mode. The way in which you written the code, same code only we got right. The 13th mode is an output mode. Okay. So similarly, we can go with the input also. And for loop. So for loop, for initialization, condition, expression. So the general format is you will have some initialization and condition and then expression and do some activity. So initialization, I is initialized to the 0, and checking the condition. Condition is I is less than 20. Then by after running the one operation, the next operation I increment will be I equal to I plus 1. Okay, I equal to I plus 1 until 20 operator it will run. So digital write 30 will be high and delay for 20 milliseconds. Okay, for 250 milliseconds, and digital write 13 the low and delay for 250 milliseconds. Okay, and another one while loop. So to check whether the condition is valid, some variable where there is a conditional operator, then do something. So while variable is less than 200, test if less than 200 and perform the operation. Okay, so perform this whatever the condition it is given there. And do and while. So after doing the one, we check the condition. See, there is a difference between while and do and do and while. While and do, first initially it will check it, and do and while without checking, first time it will run. After next time, the next iteration only it will check. So there is a difference. Okay. To do, x equal to sensor, the sensor readings are input and delay for 50 milliseconds. Then perform the checking x is less than 100 or not and perform some operations. And pin mode 1 pin mode, so pin output 1 set the pin to the output. So whatever the pin output, it will be setting as a pin mode. Okay, which pin is given as an output, which pin is given as an input, we have to define, is a custom one, we have to define. And as well as the digital write, which will be digiting the output in the corresponding output, we have to give the high or low. And a digital read, so a digital read, the reading the input value, the digital input value, that value it will be stored. So the syntax is digital read. And digital write, so already I mentioned digital write, you can the high value will be stored here. So for this example, is given as LED is 13th pin is connected, and the pin is 7th pin connected to the push button, and value equal to 0, variable source value is a this is 0 initialization. And pin mode setup on pin mode, LED output, LED is taken as an output device. And pin mode, pin in input, input is a push button, because when you are pressing something, the activation has to be carried out, so it will display the LED light. So pin mode is the input one. And void loop, so value equal to digital read, so whatever the value it is we are initializing the one, and whatever the value is stored in the pin mode, pin is 7th pin, the push button is giving whatever the push button value is given, that is stored as a value, then digital write, so that value, if it is high, it will take it as a LED on. Okay, LED set the value for value, it will do it. And analog read, so the value analog read pin, so you can whatever the pin we are given as a value, value will be analog, it will be reading it out. And analog write, so writing the value into the LED pin, the same syntax is given, the same program once again it is given there. So LED pin is 10, pin value is 0, and potentiometer value initialization is equal to 0. Then while the analog read, the pin value which is reading as a analog read value, it divided by the 4, and an analog write LED value output the PMW signals. And delay is all default to 1, so it is a millisecond, 1000 means 1000 millisecond, though it is equal to 1 second. So if you are putting a milli, so set the value equal to millisecond, so that is also option available. And you can have the command called minimum xy, so comparing a two value, it will calculate the minimum value. Okay, it will set the minimum value. And similarly, you can calculate the maximum value using the max command, and this is the minimum command, the value will be stored in the minimum command. And a random seed, so if you want to generate a random number, you can use the syntax called random seed. S should be a caps letter. And see, if you look at the, if you want to create the random between the two numbers, say 100 to 200, if you want to give the random number between the 100 to 200, you got to use the random. If the random seed, usually it will be going 0 to 1. Okay, it will generate the random number. So the random number initialization, and then the LED equal to 10, and random seed limits milliseconds. And random number, whatever the rand is given 255, so the numbers from 0 to 255, if you are not defining anything, it is taken as a 0. Analog write LED with random number, so that random number initialization 1, this value, whatever the value, it will LED will on, and delay for 50 seconds. And serial begin rate, the void setup, serial begin rate, see, this is the baud rate. The baud rate is the data transfer rate. Okay, it's a data transfer rate. The default one is 9600 bps, and you can change it to 11200 or 14,000 also is available, 15,000 also available, depending upon the application you have to use it. And print means printing the output command, analog output. So here the serial begins, so we have to define the baud rate, and correspondingly the print you got to read the analog one and then delay one. Now we are going to see an exercise number 1, a simple exercise, fundamental exercise, LED on or off. So if you look at the code, LED is connected to 30th pin, LED is connected to 13th pin, and push button is connected to 7th pin, and we are defined as a variable as 0, and serial with the baud rate, and pin mode LED output is defined as a LED 1 output, 13th pin we are giving a output, and push button input as the push button. Okay, input as a push button which is connected to 7th one. And the void loop, so digital read, so we are reading the push button value, what is the input value is given by a push button, whether it's a high or low. So if the value is high, so they're just pressing it out, then the LED should be on. Okay, LED should be on, turn LED should be off. Okay, and else if you are leaving it on, LED should be on. So depending upon your requirement, you want here the circuit diagram where the pin is connected and how the push button here. If you look at that, there the push button is connected with the breadboard, you are connecting the two off of it. Okay, the similar way you have to connect it out, so then only it will work. And we are given the two case study. After completing the one, you can try with this case study, so that you will have an idea, because while doing an programming, you have to do on your own how the sensor LED is working, push button and LED using the one. Two case studies are given, some logical and operator are given. And interfacing analog, the second exercise will be interfacing the analog uh, with sensor potentiometer, Arduino programming. So constant input analog 1, A0, analog 1, analog pin is given as a A0 pin. Analog output pin is 6th one is given it, and in sensor value is 0, because we are initializing we are removing the output value as 0. Serial baud rate is 9600. The sensor value analog read, analog pin, whatever the value analog pin which we are getting the signal, the same value will be given as a 1, and output value map. So sensor value is mapped between this potentiometer map between 0 to 1025, and this value we have to map it, so that whatever the potential, because it is going to rotate it, so we must map the value and accordingly it will work. Okay, the analog value output value, print the result serial print sensor, and print the one sensor value and print the voltage and print the output value. So using this program, by varying the potentiometer, we have to find it out whether the LED is glowing continuously or not. Okay, LED, you can control the LED where instead of either on, if you are changing the potentiometer value, okay, by changing the knob here, potentiometer knob, the LED intensity of glowing can be varied. So similarly, the two case studies are given using the whatever it is given there, LED on or off, and this LED potentiometer also is given. So you can try on this one, so that you will have an idea. And if you look at here, digital input sensor, ultrasonic sensor. Okay, most of them will be using ultrasonic sensor for avoiding obstacles and other things. So you see a sensor value, and long is a variable, duration inches and centimeter, and float the distance. So input device, the input value 7th is given as the input value. Output value, Arduino board output value is 8th output. Initialize the serial communication 9600 is the baud rate, and a digital write. So 8th pin, it's given as a digital write. Okay, digital one, and low delay microsecond. So 10 second, it is a microseconds, and digital write, eighth pin, it will be taken as a high, delay microseconds, and similarly the pulse in pulse one. So depending upon the value, it will find out the distance. Okay, the formula is 3/4 duration, whatever the duration it is calculated here, pulse in the 1/7 when it is high, because when the signal is returning back, that value we have to take as a duration into 0.034 divided by 2. So you can calculate the distance, and you can print the distance, serial print, it will print the distance, and centimeters, because we want in centimeters, so we can print the what is the distance and delay. And there are the two case studies are given, so you can try these case studies also, so that you'll have a better understanding. And next exercise is a servo motor. So how to connect the servo motor? So servo pin is connected to 9th pin, servo equal to servo. So this is the syntax, and integer angle we have to give initialization angle is 0, and servo dot attach servo pin. So whatever the servo, because we have to use the header file. Okay, header file servo dot h. So that pin, the 8th pin, whatever the value to store there, it will store it here, and scan for 0 to 180 degrees. For angle 0 to 1000 angle, the angle can be added, and servo right. So the writing, so it will be rotating the one accordingly, whatever the one. If you want to reverse back, so 180 to 0 degree, the angle minus minus. If you are giving it, it will rotate in a reverse direction. So forward direction this one, and angle plus plus is forward direction, angle minus minus the reverse direction. And you can have these two case studies, how it can be done, so for better understanding. You can see that this is the case study. Servo motor should run, and otherwise the motor should be off. So if there is a less than 30 centimeter, the motor should be on, otherwise the motor should be off. So this case study you can try it. And next one, servo motor with Arduino with a potentiometer. So you can have with a servo motor here, and a servo.h and a baud pin. So you can add with the potentiometer, little bit complication is happening, and using the servo motor 9th pin is attached, and analog read. Once it is analog is the reading, servo motor reading, the mapping the value in the potentiometer, okay, potentiometer, and servo write the whatever the value is, so servo write and delay. So accordingly servo write will be rotating. So you will have a two case study on this, how potentiometer on corresponding to the one, and angle degree. So case study 2, potentiometer LED 1 and on. And servo motor is ultrasonic sensor. So we are putting another sensor, ultrasonic sensor, how to do it, okay. So you can have with this program. So this is the digital pin and echo and servo sound. So we can serial bot 9600 pin mode and echo pin, okay. Echo pin as output, set as an echo pin. Then long duration, we can have with a long duration, so that you will have the data more. And clear the trigger pin. So you can have the trigger pin low and delay the microseconds for 2 seconds, and then you can try with a 10 microseconds, and digital pin, digital trigger pin high, and delay for 10 another 10 microseconds, and digital trigger pin low. So like that you can have the triggering pin when it is reading the ultrasonic sensor. The distance can be calculated according to the distance. Some action can be, the distance is less than 10, and you can have the distance is 60 to 10, what the distance more than the 60, and you can have the system is more than 60. So like that you can have a display out of it. Now we have a two case studies. So case study you can have, if obstacles avoidance to 20 to 30 centimeter, the servo motor should run the particular angle, and obstacle distance between the 100 to 20 centimeter, servo motor should turn particular angle, LED intensity will glow accordingly. So like that if you are trying with this case study, you can have a better understanding. Thank you.